you've got an equilateral triangle. I'm just going to do it a little differently. So if I sketch the outline of this equilateral triangle on my page, you've already got it, but you may need to look up here to kind of see where I'm going. I have an arrow pointing up on my triangle. You don't have to put that because you can't really rotate yours. But if I rotate this until it clicks back into itself, how far have I rotated that? Uh, 180 would be if the arrow was then pointing down. So it's a little less than 180. I think it's more than 90 because 90 would be putting the arrow. How did you get that, Riley? You just know? Yes. Okay, so the angle of rotation can be found by dividing 360 by the number of sides of a regular shape, where n is the number of sides. And what's a regular shape? No. Nice try, though. What makes this an equilateral triangle? And? Three equal angles. Good. So all sides and all angles are equal. That's what makes a regular shape. Okay? So in this case, the angle of rotation is 360 divided by 3, which is 120 degrees, which is exactly how far I've had to rotate this to make this angle, this point, fit into that lower right point there. And if I keep rotating, then I have more angles of rotation. So the next one would be plus 120 or 240 degrees, right? And then if I go again, I'm all the way around at 360. Now, what I want you to do, Daniel, head up, please. What I want you to do is on your picture, you can just sketch it. In fact, that's what I'm going to do. I'm going to just sketch this line out a little ways. Okay? This is an exterior angle. We call that an exterior angle. When you've drawn a line straight out from one leg, and the angle that's made from an adjacent leg, adjacent meaning next to, this is an exterior angle. How many degrees do you think that exterior angle is? Well, hang on. Let's back up a second. Oh, Cody, you have an answer?
Well, 240 because the angle's 120. So, wait, no, sorry, that'd be given to 180. Never mind.
Okay. All right. Okay. We'll strike that from the records, but I think you're on the right track. Let's look at the interior angle. This is an interior angle. And if this is a regular shape, then all of my interior angles are equal. How many degrees are in a triangle? Yeah.
180.
Good. All triangles have 180 degrees. So in this case, the number of degrees inside the triangle, if I divide that evenly by 3, I get an interior angle of 60 degrees. So if this is 60 and this is a straight, if this is 60 and this is a straight line, how many degrees are in a straight line? 180, right. So if this is 60, how much must this be? 120. Right. Wait a minute. Those are the same. So finding an exterior angle, And finding the angle of rotation, same thing? Maybe. Let's look at another shape. I think your next shape is a square, is it not? I'm going to trace my square. Tell me something that we know about squares. What makes a square a square? 4 equal sides, 4 equal angles, and those angles are specifically, they're all 90s, yeah. And if I draw out here, if this is a 90-degree angle here, what's that one? 90. Yeah, 90, because 90 plus 90 is 180. A straight line always makes 180 degrees. So my exterior angle is 90 degrees. And my interior angle, and how many degrees of rotation do I have to go from this to that? Right. My degrees of rotation degrees of rot, okay, are going to be 360 divided by 4, which is 90. Coincidence? I think not. Right. So your exterior angle and your degrees of rotation are the same formula. Okay? The interior angles, now hold on a second. There was 180 degrees on the inside of the triangle. How many degrees is it total on the interior angles of a square? 90 times 4? 360 degrees, right. How do we know how many degrees are in a shape? Guess? Oh, you count. What do you count? Okay. Let's back up a second. If I drew an exterior angle off of each of these, what's the total sum of my exterior angles? This one, plus this one, plus this one, plus that one. 360 degrees, right? So the total sum of my exterior angles is 360, and with a square it just so happens that the total sum is 360 as well. What if I do the same? I'm going to go back up to my triangle here. What if I do the same here and here? How many degrees here? 120. Because here's a 60, right? And 60 plus 120 makes 180. And this is a 60. So this is also 120 degrees. And what's 120 plus 120 plus 120? So the interior angles are different, but the exterior angles on those two shapes are the same. Let's look at another shape. I'm going to use now this guy here, the pentagon. So if I'm rotating this, my angle of rotation, how far does it have to go before it clicks back into itself? 360. The number of degrees of the exterior, total sum of the exteriors, divided by 5, the number of sides. And if my memory serves me, that's 72 degrees. Now I know it's not Harry Potter, but you two are getting a little too sleepy. Come on, wake up. Okay, so that means that my exterior angle here is 72 degrees. And if I multiply that times the number of sides, what am I going to get? Yeah. What's the interior angle? How much is that? It's going to be 180 minus 72 is 108 degrees. So how many degrees are there total inside a regular pentagon? 500. 108 times 5. What's 100 times 5? What's 8 times 5? Put them together. 540 degrees. Because there's 5 angles. Six-sided shape. I want you to... Hey, you're not writing any of this. I already know this. I'm trying to teach you. Write this down. Exterior angle. How much is that? You got me? 60. 60. I'm handing it over here. 60. If I do this, oh, hang on a second. Before I do that, how much is the interior angle? If this is 60, how much is that? 120. 120. Good. If I take and draw a diagonal, I've just bisected this angle. This 120 degree angle just got split in half. So then I have 2 more 60s. Yeah? And if I do that here, and if I do that here, yes, but specifically what kind of triangles?
Equilateral.
How do you know? It's true. How do you know?
Because in
Prove it to me.
a triangle is 180.
You can
The
see
one
it.
side is 60 and the other side.
You can see it doesn't cut it.
Wait, you just put a regular hexagon.
Yeah,
I don't think you did. I don't think you did.
If one side is 60, the rest of the sides are 62. So if it's in equilateral.
because like a triangle.
But the sides aren't 60.
But no, look.
But
you
if
have
the angle is
measured right there. So
the angle is 60 degrees.
The line
That
is
means
straight.
And a triangle has to equal 180.
Okay.
So if one side
Yeah.
is 60, then all of them have to be 60.
The opposite. I mean, technically,
False.
one of them could be 59
False.
and one could be 61.
No, no, no. It's not true that every triangle that has a 60-degree angle is an equilateral triangle. That's what was sort of said right there. That's not true. However, I'm bisecting all of these are 120-degree angles, and I'm splitting them in half. So yes, these are all 60s. And if you have 3 60-degree angles, then you also have 3 equal sides. So a hexagon is kind of a special shape. It's made up of 6 equilateral triangles. It's kind of a cool shape because of that. You can do a lot of really kind of cool things with it. So the interior angle 120, exterior angle 60. Let me ask a quick question here. Let's go into the assignment here a bit. Let's look at number 9. How many sides does a regular polygon have that has an angle of rotation equal to 18 degrees?
100. Wait, no.
No, what am I going through? 360? 360 divided by n equals 18.
200.
Hold on. 200 sides? I don't think so.
Wait,
Okay, hold on. Quit trying to do it in your head.
20.
Do it algebraically. How do I get the n out from underneath the denominator? Multiply both sides by n. So I get 360 equals 18n. Now what?
Divide by 360.
By 18. Divide by 18. What's n?
20.
Right. Now, quick question. What happened when I divided by 18 is I took 360 and I divided it by the degrees of the angle of rotation to get the number of sides. So I just did a whole bunch of math when all I really have to do is switch place for the 18 and the n. I call it the trig. You'll see it next year a lot. It's called the trig shortcut. These guys just have to switch place because that's what happened here. Okay. All right, one more thing real quick. Coming back to this, you guys told me that a triangle has 180 degrees, right? And I agreed. And you said that a square has 360 degrees. Let me show you a quick and easy way to figure out the number of degrees of any shape. Okay? So I'm going to pick a point on the square, any point. I'm going to pick this point right here. From that point, I'm going to draw as many diagonals as I can, which in this case is only one, which turns the square into what? Two triangles. And we know that triangles have how many degrees? And 180 plus 180 is 360. So let's look at see if that works for a little bit more complex shape. What if I do that to the pentagon? What if I pick a side, or pick a point, pick a vertex, and I draw as many diagonals as I can from only that one point? And remember, diagonals don't necessarily split the point or the shape in half. They just go from point to point. It looks to me like I can split that up into 3 triangles. Each triangle has 180 degrees. So 180 times 3 equals 540. That was the angle, that was the measurement that we found before. All right. I'll let it slide this time. Yes?
A question. Why is it 180?
All triangles have 180 degrees. It just is a property of triangles. All triangles. If you add up the angles inside any triangle, you will always get 180 degrees. Unless it's not a triangle, then it won't be 180. Okay? So let's look at an octagon. So I'm going to pick this point here, because drawing from left to right is easiest, and I'm going to connect as many diagonals as I can. Each diagonal is going to create another triangle. How many triangles did I make? 2, 3, 4, 5, 6. Yep. So 6 times 180. 1080? Is it? It might be. I should know it's 16. Yeah, 1080. So the interior of an octagon has a bunch of degrees because each angle is obtuse. But the rotation, or the exterior angle, still equals just 360. How could I do that without using the diagonals? So a triangle has one triangle, 3 sides. A square has 2 triangles, 4 sides. A pentagon had 3 triangles, 5 sides. An octagon had 6 triangles, 8 sides. Yes?
Take the number of sides and you subtract 2.
Bingo. Times? Times 180. Good. So to get the number of, I'll write it down here, the number of interior degrees of any polygon, not just regular ones, equals 180 times the number of sides minus 2, where n equals the number of sides. The number of triangles that you can make in any shape is always 2 less than the number of sides. Alright, and that is it for me. I am out. I would walk out the door if I could and just